Hi, my name is Greg and I am the author of Grasshopper Tekla Drawing Link, a set of over 100 Grasshopper components aiming to give you the possibility to automate your Tekla structures drawings. With Drawing Link, you can create entire drawings or just a subset of them. It's all up to you, to your needs, how far you will go with the link. But before you start the journey, it's always wise to gather the party. And together with Chris from learngrasshopper.com, we have prepared a whole course about Grasshopper usage inside of Tekla structures. Chris focused on the model part with a well-structured modules about the Grasshopper Tekla Live Link. For me, it was quite simple. As the author of the drawing link, I tried my best to provide guidance about the drawing part of Tekla. And today, you have the opportunity to see how one of those lessons look like. In a few seconds, you will see how to project 3D model geometry onto drawing views coordination system. And it can be a tricky stuff, but with the help of Drawing Link, it will be easy. So if you want to get more, please join the waiting list on the grasshopperintekla.com. Let's go! Hello! Today we will focus on projections, on all of those operations which are needed to transfer the 3D geometry to the 2D views. And you have to know that the Tekla Drawing Open API doesn't offer the possibility to get the projection results which you see on the views. So you can't ask Tekla, hey, please provide me all of those lines which are visible on the front view for that part. It's not possible in the Open API. So we have to recreate this process. We have to get the 3D geometry, the B-reps from the model area, and after that we have to cast proper shadows on our views planes, and by doing that we will obtain the proper representation on the 2D views. So let's find out how is it working. At the beginning, I will focus on this inner layer of this sandwich wall. It has some openings, it can be viewed from different angles, so let's find out how we can get the projections, the borders of this 3D element in 2D space. So I will start with just selecting this object with the help of the Live Link, and after getting it selected, let's get the B-rep of it. So convert to B-rep with the normal type. We will not think too much about the differences now. And as you can see, I get the 3D representation of that object. And of course, currently we see it as a 3D B-rep. So now I would like to cast it. And for that, I will use the B-rep projection border. And that component, it needs two different inputs. Of course, the first one is just the B-rep, and this is the only necessary one. And as you can see, we currently obtained some results. And it's quite interesting because we just get the projection on the global XY plane. As you can see, this is exactly like we would like to see this wall from top. So now I will try to get the projection, but looking on that side from that angle. So this will be the YZ plane. And for the orienting inside of the B-rep projection border, I have just to provide the proper plane. So I will just get the proper plane YZ. And after that, I will get the projection. And as you can see, now on the top view, we are seeing this wall from that particular angle, from that by casting it to the proper plane. And on the right side, on the downstream side, we see three different outputs. Let's find out what it is. So the first one is the boundary. And as you can see, I will just provide some generic geometry to see it a little more. So the boundary is just the outer contour of our B-rep. So this is the boundary. Probably you already know that the hole is a list of all of the holes which are inside of our B-rep, looking at that particular angle. And the last one is the union rectangle, so just one box which for that element is just the same as the boundary, because this wall is rectangular in its shape. But if we would just get some cut, let's just do something crazy, and I will create the cut for that wall, just to show you that what is the difference between, okay, here it is. I will recalculate this one, okay. And now the union rectangle is the bounding box onto the plane, but the boundary itself is taking into account that opening. Of course, if I will switch the way how I am getting the B-reps, now I am getting the normal one type. So if I will change it, for example, to the row, then it will not include the holes or the openings, those windows, but also any other type of the openings. So please be aware which solid type conversion you are using. By default, it is normal, and in almost every cases it will be enough. So the B-rep projection border needs at least one input. You have to provide the B-rep which you want to cast. Then you have also the possibility to provide the plane on which you want to cast the B-rep. If you will not do it, then you will just get the global XY. And for some cases, maybe it will be exactly what do you need, because you already have oriented the B-rep in some previous components. But for our case, let's stick with that. So for now, I will just use this B-rep projection border with the provided plane to see my inner layer of this sandwich wall like that. And as you can see, we can get the boundary, you can get the holes and the union, so the box which is around our B-rep on that particular plane. And now the question is, okay, so how I can get those individual lines, those individual segments of that border? And for that, you can use this component, find visible edges. And I will use for now the boundary for this component. And as you can see, I have to provide also the second parameter, the vector, and it is named the viewing vector. So let's start with some helper value list. This one, viewing direction. And how is it working? It works like that, that now we are trying to see our border from the left side. And as you can see, if we are watching it from the left side, then it is like that. We see those things on the left. If I will change the direction, so for example, now I want to see my boundary from top, then it is like that. And you get the point. And of course, the question is, what is exactly under the hood of this viewing direction? And here we just see the definition of the vector. So now I am trying to see what edges are visible when I am looking with the unit y vector. If I will reverse it, so in the y coordinate it will be -1, then of course I will be looking from top. Let's find out. If I will switch to the top, then the vector, the viewing direction has been changed. You can provide on that place whatever vector you would like, but by default, usually on the drawings, we are trying to see our things from 4 different sides. So that's why the viewing direction component has been established, just to give you the fast way to get those different edges looking from different directions. And when we will try to see it from the left, it's quite nice occasion to see a different type of the outputs of it. Because as we can see, I will just provide some panels to give you more feeling what is going under the hood. Here are the edges, so I get 2 lines, and also I will provide you with the extremes. So maybe a little something like that. Okay, now it should be a little better. Now let's find out what we see. So we are trying to check which edges are visible when we are looking from the left. And as you can see, the first output, the points, there are 4 points which are visible from that side. So we have the points from the first edge, the second edge, and that multiplied by 2, it gives us 4 points. So this is the first output. The second output are the edges itself. So if you would like to find out, okay, so what are those edges, then the second parameter, the second output argument will provide us that information. And extremes, as you can probably imagine, extremes are the points which are the furthest, which are the most offsetted, like those two ones. So it all depends on your needs, how you would like to process further those visible edges, but you can work on every point, on the edges, or just on the extremes, because yeah, you are trying to insert only the dimension for the extremes of the concrete. That's the main point for this find visible edges with the help of the viewing directions. And of course, here you can provide more than one vector for the same curve. So for example, I will change the style for the checklist. And now I would like to process my curve from the left and also from the top. And if I will do that, then yeah, let's just see this one. So now I am getting trees as the outputs. So I am getting the trees corresponding with the first viewing direction, with the second viewing direction, and the edges and the extremes, etc. The same rules as usually applies. So you can provide multiple viewing directions, and then you will get those castings from different angles. It all depends on your needs. The previous samples were warm-up ones. Normally, you will not pick elements in the model. You will not know that you are working on the YZ plane. You have to somehow get it from the drawing content itself. So let's find out how this combination of the B-Rep projection border and finding visible edges will work in the drawing area. So as usually, I will start with the active drawing just to get the starting point. And I need the data viewer. I always like that component to see what's going on. Okay, so here is the drawing. And after getting the drawing, let's find out the main part of that cast unit. So I will get the drawing source, just to get the model object, which was used for creation of the drawing. So here it is. It was some assembly. And of course, at that point, I don't know which exactly, so I have to deconstruct it into those smaller pieces. And now I get some main parts, some secondaries, but now I am mainly thinking about those main parts. So this main part, I don't know where exactly is it the right one. So I will get the B-Rep of it in the global coordinate system, in the model coordinate system. And here we can see that I will just restore it. Okay, so this is the piece, the inner layer of that sandwich wall. So exactly the drawing source, the main part is what I now want to use it. And as I said, I don't know on which plane I should cast this B-Rep. This is not so straightforward as in the previous sample because I have only the view itself. So of course the question is, okay, so how it can be done? So let's find out at the beginning how many views are in the drawing. And probably I have already removed all of the other views, but let's find out. Yes, so now that's only the one view. But of course, when there are multiple views, then you would like probably to filter out them by some property or by some type. So when you will get the view properties, this one, then I'm getting the type of those views. And this is just the front view. And I will use that to filter out. So I will connect the values, all of those views and all of those types, and I want only the front view to be returned. So I want my script to work only on the front view. And as I said, in that sample, I have only one view, but in your real production drawings, you will get multiple views. So for now, I just filtered the set of all views only to those front ones. Of course, you could get more than one. So then based on some tags or by some names, you have to filter out what exactly you want to work on. But for my case, it's that front view. Then I have to once more get the properties of that view just to make it a little easier. And here I am getting two coordination systems, the view and the display. And in almost every cases, when you are asking, okay, so what do I see on that particular view, then you are interested in these display coordination systems. Why? Because it takes into account all of those rotations which were applied after the creation of the view. So I will be using the display coordination system. And now I can use, like previously, this BREP projection border. So I will connect the BREP from the main part. Here it is. And now I get the plane, the exact plane which is used for that view. So I will use it like that. And I am getting the same results as previously. But as you can see, I have not hard-coded that plane like previously. Previously, I just said, hey, I am interested in that plane. And here, this is not the case. So if I will now create some arbitrary top view, which is completely different where it is, okay, here it is, with some default settings, so it will probably has a lot of different things on it. But now, when I will just recreate these all views, then I will get two different views, as you can see. And my filtering is working in that way that I am getting only those front views. So the result of the script is exactly the same. But if I will change this to the top one, then you see that completely different 2D representation was displayed. And exactly this is what I wanted to achieve with this filtering. So based on where are you now working, what are you thinking about, then this component BREP projection border, it internally orients the provided BREP with the provided coordination systems, which is dynamically acquired from the view itself. And after combination of those two inputs, BREP and the plane, we will get the boundary, the hole, and the union rectangle exactly in the same way like previously. So that's the main point of the BREP projection border. I will go back to the front one, and here it is. So as you remember, we don't need to provide the plane for that component. By default, it will work on global XY. And yeah, usually you don't want to work on the global XY, maybe on some GA drawings, but here this is not our case. So we always want to orient that geometry. But we can orient it not only in this BREP projection border, but with some pre-steps components, if those are our requirements. And for that point, we can use the vanilla orient component, which just gets some geometry. So for this one, it would be my geometry. And it also needs the mapping between the source coordinate system and the target coordination system. And for the Tekla, those coordination systems which are returned by the view properties component, they are in the box of the source coordination system. So after marking it like that, then I am getting this oriented BREP. This is still the 3D geometry. Please look, this is it. It has some thickness. So if I provide this geometry to the BREP projection border, then I will get the same result as previously when I used that plane. So as you can see, the BREP projection border in its internals, it orients the provided BREP with the plane, and then it casts some shadows. But if you provide already casted geometry with the orient component, then you don't need to provide once more that plane, because you will double orient and you will get some messy geometry. So if you are interested in just orienting the whole BREP and seeing its representation in Rhino, then use the orient from the vanilla Grasshopper set of components, or you can use this simple orient, which comes from the Tekla Drawing Link. And as you can see, it is a simple one, so it has just one type of conversion. So if I provide here the geometry and the plane, then I will get exactly the same results. They are working the same, but you have just one extra input. Of course, you have to provide geometry, but there is only one plane to provide, the Tekla plane. So it just was created to streamline your approach. But there is also one more reason why I developed this simple orient. So if I will change my whole script, and I will be not interested only on those things which are coming from the front views, but I would like to work on every view. You know, just some crazy idea that I am playing 5D chesses and now I want to make operations on every drawing view. Because yeah, I'm the smart guy and I will do it myself. So let's find out, is it even possible and how it will work? To make it even more complicated, I have now shown all of the layers of the sandwich wall. So I have 3 layers visible, different parts, different geometries. So yeah, let's find out how we can tackle getting those geometries casted on the proper planes with the combination of those components. So I will start exactly the same with the active drawing. But now I will not be interested in the source because I'm interested in every part which is visible on the drawing. So I will get all of the views, every view. I will not filter them out. Then I will get all of the parts, all of the objects which are visible on the views. And here I am getting the parts. So that is what I am interested in. So I will just use the part view types. I will use the part types, drawing object types, and just change the representation to this smaller one. And now we are interested in the parts. Here they are. Okay, I will use this searching using key, and I will provide this, and now I get the match. So I get 2 different branches, and as you can see in the indices, one is coming from the first view and the second is coming from the second view. So now I have to somehow cast them to the model objects. So we will use one of the components from the previous modules, and now I'm getting the model objects. After that, exactly like previously, I have to convert it to the brep. So now I am getting those breps, but they are doubled. So because the same parts are visible on 2 different views, and of course in 3D they are the same, they are matching. But I have to somehow get them in the oriented way. So I will use now the component simple orient. And how is it working? I will just a little reshuffle those things. I need to provide geometry and the plane as previously. The difference is that now I'm providing the geometry as a tree. Previously it was just a single item, so it was not, too heavy to think about how is it working. But now you can see that the simple orient is getting the geometries as the tree and getting the planes as the list. Also in the description of the component, you can see that this component handles the convention path as we talked in the previous module. So how we can use it? If I will get the view properties from those 2 views, so now I am getting 2 different display coordination systems, and I will cast it as a plane, then I will get those geometries properly casted. So now I have the tree with 6 branches because I had 3 parts visible on each view. So multiplied by 2, it gives me the number of 6. And if I will use just for the demonstration purpose the explode component with these match outputs, and I will just provide it to the proper geometry just to see it what is going on, then you will see that I am getting the 1 layer on the first view, the same, and the inner layer. So those first 3 things, as you can see from the branches, the first index is 0, so we are working on the first view. Those are coming only for that particular view. So this is how simple orient is managing its indices. As I will use the same workflow for this one, then I will get those geometries casted only on the second view, this top view. And you can see, okay, it was what I was expecting, what you were expecting. But the difference between the vanilla orient component and this simple orient is that if I will do exactly the same thing here without any, matching, duplicating data, then I will also get something. I get 6 branches, but its structure is completely different. And it's quite hard to understand how Grasshopper has combined those geometries, those 6 geometries, with 2 planes. And as you can see, this component has been run 12 times, so each with each, and we are getting twice as much outputs as we would like, because at the beginning we had only 6 geometries in 2 different planes, and this convention of paths is preserved in those indices. So this component has run only once. It gathers all of the inputs, matched the correct views with the correct geometries, and provided us what we wanted to have. So if I will just recreate this explode tree for that one, then I will see that, well, I get quite a messy, because here is that, here is that, here is that. So I have to, in the next steps, do some splitting or just some getting list items from that branches. It can be done, of course. In Grasshopper you can do almost everything, but the simple orient was developed just to decrease the need of further adjustment of those branches into smaller subsets. So if you plan to work on multiple views at once, then the simple orient will do this path convention for you. But is it the right way of doing? It depends on your needs. I usually prefer to filter the views which I am interested in, because the front view has completely different logic than the top view. Those rules are different. So I don't see the point of doing everything in one big place, which will be very hard to maintain. So just to know that the simple orient can be used for as the replacement for the standard orient component, but all of them, their main purpose is mainly to provide the brep for that component, or maybe if you are orienting some lines, then you will use just some extracting start and endpoints. So from the geometry perspective, of the drawing link, almost every time you will need to cast the 3D representation with the help of the brep projection border. And of course, in the background, it makes some stuff like shadow outline, like some changing the breps to meshes with some quality settings and things like that. So the set of, I think, 4 or maybe 5 components which are in the Grasshopper are packed together to provide you just a simple box, just this brep projection border. So this is the first component, which you will use quite often. The second one are those fine visible edges. And together with this viewing direction, it drastically decreases the complexity of getting the points, edges, which are visible from particular directions. And I hope that you will like this workflow, because it's very easy and convenient to get that. Okay, now I'm watching my element from the left side. What do I see? Okay, this and this, some stuff like that. And the last component, this simple orient, which can be replaced with this orient, because internally they are working on the same principles, but here we have just one input parameter, only the plane, to decrease your headache that, okay, so this is the source or this is the target, and why I have to connect the Tekla view to the source. This is so strange. So simple orient is just to make your life easier. And that's all what I wanted to say about the projections and orientations. Thanks. It was quite a lot of new stuff, but probably in your case it's not enough, because okay, now you have the projections, the 2D image of your elements, but it's still not enough, because maybe you need dimension lines, maybe you need some annotation symbols, maybe some text, maybe associative notes, maybe you want to position your views in some other places in the drawing, or create the whole drawings from the scratch. All of those questions are answered in the course, which you can enroll in the Grasshopper in Tekla.com. Please join the waiting list and see the details on that page. See you next time.